Good afternoon, everybody. We are going to be going over our 2.3 notes, which is evaluating functions. The learning target today is I can read and use function notation to evaluate functions. We have two vocabulary words today. The first one is evaluate, which is finding the value of an equation by plugging in given information. And function notation is when you're going to have something else used in place of y, and that something else is going to look like this. And you read that as f of x, okay? So whatever letter is in front, you're going to name that letter, and then you're going to say of, and then whatever letter's on the inside, you're going to say x, f of x. So we will use that in place of y. So whenever you are used to seeing something like y equals 2x, we will use f of x equals 2x. This right here is function notation, okay? Now the good news for you is that they both mean the same thing. So y are your input values, your range values, I'm sorry, not your input, your output values and your range values and your y values. And f of x, this function notation, is still your output, your y values, your range values, okay? All right, so we are going to practice evaluating functions without function notation first because this is something that you should already know how to do. Let's use our function machine example, what we talked about yesterday, or the last time we did these notes, to apply some math. How would we evaluate the following equation if x equals 6? So since we already know the value of x, we can take what x is equal to and plug it into this equation for x. We would have y is equal to 3 times 6 plus 1. So think back to Unit 1 when we were solving equations and then we were checking to see if our solution or if what we got for our answer was mathematically correct by plugging it back in and then simplifying. That's kind of what we're doing here. So this will be y is equal to 18 plus 1, and then y is equal to 19. So if I plug in 6 into x, and then I mathematically work it out, I get y is 19. So this says, what is our input? Our input is 6. What is the function machine? That is our equation, okay? That is our 3x plus 1. And then the output that we got is 19. Very straightforward, very simple. You input 6, you simplify, you get a number out. When you look at the same problem with function notation, the process is going to be the same, but the way that you are presented the information is going to look a little bit different. So it says I want to look at the same example as the one above, but this time look at it through function notation. So it says evaluate for f of 6. Okay, so this is f of 6. Now this originally was f of x, and what they've done is they have replaced x in function notation with 6. So all that means is my x value should be 6. So just like what I did with the problem above, I am going to replace anywhere that I see an x with 6, okay? That's all that means. Now, this is going to look a little bit weird to you because you're like, boo, there's not a y anymore. Now there's this f of 6. f of 6, we're still just saying that I am inputting 6 into my function. 6 is my input, okay? This side is going to be 18 plus 1. This is going to be f of 6. I'm not solving this. I'm not doing anything with this. It's just going to stay there the entire time. f of 6 equals 19. And 19 is still my final answer. So what is our input? Our input was 6. What is our function machine? Our equation up there. And then what is our output? Our output is 19. Now the reason that we do this is whenever we are dealing with functions. So what this means right here is when I input 6 into my x, I'm going to get an output of 19. So it kind of works like a coordinate. All right. All right, this section says use the function f of x equals 3 minus 2x to evaluate the following domains. Remember that domain represents our x values, okay? So each of these, 1, 2, 3, all the way through 6, is going to be exactly what we just did up above, but we are going to use this equation for each one of these different inputs, okay? We're just going to use the same equation, and we're just going to change what we're inputting each time. So on this first equation, this is going to be 3 minus 2, and then for x, I have to input that negative 2. Okay? The left side is just going to stay. Now what we have to do from here is we have to follow PEMDAS, and PEMDAS tells us that we must multiply first. So I have to do this weird funky thing over here where I have to multiply -2 times -2, which is going to get me a +4. When I add that together, I get 7. So f of -2 is going to get me an output of 7. I'm going to do it again, but this time I'm going to be inputting -1 in where x was. So remember that I'm still just going back up here and I'm using this equation for every one of my problems. Okay, PEMDAS tells me again I must multiply before I can do any kind of addition or subtraction. So this will be 3 plus 2, which is going to be 5. So I know that when I input -1 into my function, I'm going to get an output of 5. This will be 3 minus 2, and now I'm going to input 0 into my function. I still have to do my multiplication first. -2 times 0 is actually just 0. So I just get 3. So f of 0 is 3. So when I input 0 into my function, I get an output of 3. There we go. Now I'm going to skip doing numbers 4, 5, and 6 only because I think you probably understand the process. These will be finished on the notes key, but just to save us a little bit of time, I'm going to go ahead and skip those. All right, so this question here says, find the range for the function below given the domain. And if you look, I've given you an equation, and then I've given you a domain. The great news about this is the process of me evaluating is going to be the same that I did here and up here. The way that I'm presenting you the content just looks a little bit different. So each of these values right here are 3 separate x values. I can write this as f of -5, f of 7, and f of 13 if I wanted to. But when it comes down to it, really all I'm doing is taking my equation and plugging in each one of those domain values individually and evaluating 3 separate times. So using my equation there, plugging in my domain values for x, and then I'm just going to simplify that. So this first one is going to be 4 minus 10, because I've got to do 2 times -5 first. 4 minus 10 is -6. Here I'm going to do 2 times 7 first, so that's going to be 4 plus 14, which is 18. And then over here, I'm going to do 2 times 13 plus 26, which is 30. And so the way that I would write my range is I would do my squiggle, and then I'm just going to list those 3 values that I got for my outputs, -6, 18, and 30. I would do the same thing for number 2 down here. I'm not going to do that. I'm going to skip it, and I'll do it for the notes key, but just for time-saving purposes, I'm going to do that. Let's review some of these things for stuff that we've done previous. So this is all Unit 1 review. Not all of it, but some of it is. This is 1.5, where we have to solve the following equations for y. So remember that if I'm trying to get y by itself, I have to add and subtract everything away from that first. So my first step would be to subtract 4x on both sides. We have 3y equals, this is going to be -4x plus 12. Remember that I cannot combine those two things because they are not like terms. One has an x and one does not. From there, I would need to divide everything by 3. And we get y is equal to -4/3 x plus 4, because 12 divided by 3 is 4. I would like for you to do this one over here. I'm going to skip it for now, but it'll be in the notes key. Okay, number 3 says, write an inequality from the given information. Each class at school cannot have less than 15 students in them. So x has to be greater than or equal to 15. Letter B, each class at school cannot have more than 32 students. X cannot have more than 32 students. Yeah, X has to have more than 15. Each class at school cannot have more than 32 students. Okay, sorry. So X has to be less than or equal to 32. Sorry, I had a brain fart right there. So right now they're saying that your X values have to be less than or equal to 32. And for part A, it says your X has to be greater than or equal to 15. So 15 is the minimum amount of students I can have in a class, and then 32 is the maximum amount of students I can have in a class. So when I write this down as a compound inequality, it's going to look like this. 15 is less than or equal to X, which is less than or equal to 32. Okay, this is saying right here, that's part A, where your X is greater than or equal to 15. And then this over here is part B, where your X is less than or equal to 32. That's how you write compound inequalities together. Now, what we're going to do right here is go backwards, where I've given you a graph and you have to write the inequality. If you look here, this X value is 1, 2, 3, 4. This X value is -4. And then all of my X values that are shaded, or where the arrow is located, are larger than -4. So this is going to be X is greater than -4. Now, this inequality does not have an equal sign on it, and that's because we have an open circle. And hopefully you guys remember that a little bit from middle school. So open circle means that my inequality symbol will not have an equal sign on it. Looking at letter B, I have another open circle here, and my X values start there. That is a +2, but then they're shaded that way. Well, all of those, that direction from +2 are values that are smaller than 2. So this is going to be X is less than 2, okay? Again, I'm not going to have an equal sign on my inequality symbol because I have an open circle there. Open circle, no equal, no equal. Now, if you look at letter C, all of my values are contained between 1, 2, 3, 4, this -4, and this +2. Okay, so it's basically a combination of parts A and C. So this is a combo of parts A and B. I think I just said A and C, but I meant A and B. Now, how would I write this? I'm going to write this very similar to how I wrote this letter C up here, where -4 is my smallest value and +2 is my largest value. So right now you've got X has to be greater than -4, so that's your part A. And then over here you have X is less than 2, which is this part B over here. Now the only difference, this one's going to be a little bit different only because if you look at what is provided to you in your graph, at -4 you have an open circle, so you will not have an equal sign on your inequality. However, when you look at +2, that circle is actually a closed circle. So because that circle is a closed circle, I do need to add an equal sign only onto that second inequality. All right, this is going to help us a lot, like this graphing thing that I just did is going to help us a little bit later on in this unit specifically. But if you have any questions about finding the range using function notation, go see your teacher during their normally scheduled tutorial times. I'm going to go ahead after I stop recording this and finish numbers 4, 5, and 6, as well as the second number 2 down here. And then I'll finish the number 2 over here under the review so that you can go and take a look at that if you need to. But anyways, I will see you in the next video.